Nikki Does here with another IBM Selectric video explaining how things work, especially some of the things about the Selectric that are not quite as popular. Whoa, you say, the keyboard is upside down on this Selectric. Well, we're not going to fix that today, but what we are going to talk about is in the back of the Selectric. Back as meaning away from the typist. This is the part where the part where all of the power comes flowing in and gives this magical beast its abilities to turn fingery presses into letters on paper. So what's the big deal about the back today, you say? And the big deal about the back is that, well, the biggest deal is that my headlamp is on upside down. So let's fix that. Wow. I've taken video prep to a whole new low here. So this is, of course, the motor for the Selectric typewriter. This is the only electrical thing in here, really, this motor. You have a switch and a motor, and that's it. The only thing, there's no sensors, no other switches, just a power switch. On, off. So what are we talking about with the motor? The motor drives a belt. This belt right here, and the belt drives one shaft in the whole thing called the cycle shaft. Well, it's one line of shafts called cycle shaft and operational shaft. But we're talking about back here right now because the motor sometimes has a little bit of extra work to do on startup. So if I'm over here and I press the shift key while the typewriter's off, and I turn on the typewriter, you'll notice it just made a shifty noise. So if I turn it off and I press the shift key again, and if you've watched my video on the character selection, you'll see, on shift selection rather, you'll see that this pulley over here is the shift selector. So here we're going to see it move. The motor has a clutch in it, a centrifugal clutch. And yes, I know this annoying power cable is right in the way, but here is the centrifugal clutch. Find a different pointer for today. Every video will have a different pointer. So there's the belt and there's the clutch, and you can see the flyweights on the clutch. They swing out here to engage. When they come out, they'll engage on these pawls on the motor's shaft. Not the motor shaft, on the pulley. So the pulley is not spinning right now, but the motor can. There's the motor. And notice that the belt where that G isn't going to be spinning. As soon as we spin the motor up fast enough, these pawls will come out. The weights right here will fly out due to centrifugal force and centripetal force, and that will overcome the spring tension, bring these out, catch on the pawls, and go. And this way, the motor can have some inertia to overcome some of the things that are hard at startup, like if you had pressed shift or pressed a character. So there's really no interlock to say don't press a character when you power this up. So here's the switch. When you press the rocker over here, on, off, mine's disconnected right now, but when you press that rocker, it has the effect of pressing this switch. So if we watch the motor versus the belt, it took a moment and made a tick sound as it spun up and then engaged. Now listen carefully. That extra torque is what overcomes any of the motions that have been latched in on the typewriter before you turn the power on. Imagine inside of here, of course, there is a rotor, a rotating part that's wrapped in copper, the magnetic field portion of the motor, the spinning part, and that's quite heavy. And as that spins up, the minute this clutch engages, that's already turning with quite a bit of rotational inertia with force. As soon as that clutch latches, it is going to connect all of that rotational inertia to start the operational shaft and rotating. This side right here is the operational shaft. We'll see that start rotating right there. So if I had pressed the space bar and I had pressed shift, there are now two latched operations that are going to happen. One is the space clutch and one is the shift clutch over here. So let's do them both and see if it starts up. There, and it did them both simultaneously. Shift, let's do shift lock and space. And here we go. And the only reason that happened is because this motor has that clutch system on it. In that way, the brilliant IBM engineers were able to use a very low part count motor, something that could operate with reliability for a very good long time, and still have high starting torque like this. These motors don't have high starting torque, so that's the best way. Thanks for watching. Be sure to check out my other videos on the Selectric typewriter. And if you have any curiosities about any of the other amazing systems in this 3,000 plus part machine, be sure to send me a comment and I will make a video. Thanks for watching.